Hello friends, it's Carl here. I want to do a video today showing you some setup and I guess a few tricks for my CNC lathe. This machine is an Ikegai AX20 It's got, I believe, an 1 3/4 through hole, maybe it's 2 inch. Uses an A2-6 chuck, so it's what you'd call a 6-inch chuck machine. And it's got a 12-station hydraulic tool changer. Really what we're going to be talking about today is this Fanuc 6T control. The 6T is one of the older controls, and I believe this machine was maybe 1982. So there's a few things that it lacks compared to a more modern control. The main thing that people stumble with on this control is not having what you would call a work offset. A work offset would be a set of coordinate offsets, and on a lathe usually you just use the Z one. That allows you to shift your entire tool offset system closer or further away in Z from the chuck. Where would you use that? Well, you would use it if you're doing a lot of different setups. Let's say you're doing one setup and the bar sticks out 2 inches. And then on the next setup, you need the bar to be out a little further. Instead of having to go in and touch off all your tools again, reset all of your Z coordinates for your different tools, with a work offset system, you can just go into Z and offset the entire group of tools in or out. So usually when people set things up, they'll use the work coordinate system to shift Z around. You don't have that on the 6T control. On the 6T control, you really just have one set of offsets. And if you want to use those offsets for, let's say, wear offsets, you got nothing else to use. And also those are individual per tool offsets, not a global everything offset. So usually on these machines, you set them up using what's called a G50 grid shift, or some people will call it a G50 reference point reset. And it's really not that hard to do. You just have to get your head wrapped around how it's different. 1982, they didn't have a lot of memory. So there are things that they just didn't implement because they were expensive, because they didn't have much memory. In this machine here, when you look at the specification for the amount of memory, it's not listed in kilobytes or bytes or bits, it's listed in feet. And what they mean is it's listed in the amount of feet of paper tape that it replaces. So there's just not a lot much memory there for them to play with. So I'm going to walk you through how I would start the machine up and get it ready to run a program. Right now I've got the control off, but the fans and whatnot are running, so it's a little loud. It's going to get louder. Okay, so I've got the circuit breaker in the back of the machine on, but the control is not on yet. So turn on the control, power on. Alright, so unfortunately it's going to get louder here. Bear with me because it is fairly loud with the hydraulics on. So now we need to put the machine to the zero return point. Down here you'll see there's a couple LEDs, X and Z, that are not on. So the machine has not been zeroed. This is all control area stuff. This is machine area stuff. These are your 8 function keys. This is page up, cursor up and down. This is page up and down. All your addresses, numbers, and then some editing keys. So we are in the position screen, and by using page up and down, we can go between all the different screens in the position. So you've got your absolute, your incremental, your absolute, and then your 100% screen there. To reset the machine to do a zero return, we turn into rapid. I turn it down to a low speed, and then I move the machine off of the limit switch. So I move it in Z and in X. Now I turn the zero return switch on. What that tells the machine to do is to watch for the axes zero switches and stop the machine at the zero switch. So then I can push up in X and it will stop once it gets to that limit switch. Notice the LED is on for X. Now we can go in Z. Now Z is on. And now we can return that. We don't actually have to reset to zero here, but if it makes you feel better, we can do that. We can set those to origin. We can set those to origin as well. You just hit the axis number and origin. So now if we look in position, we're all zeroed out and our LEDs are on for zero return. What we are making today is this. This is a simple part. Super simple. So we've got some 1.5" bar stock in the lathe, and to do this part we're going to use 4 tools essentially. We're going to do a turn and face with our CNMG 80-degree tool, which we'll call our reference tool. Then we're going to do a drill operation, and then we're going to do a parting operation where it'll part off, and then we will push a bar puller onto the end, the cutoff end, open the chuck, pull it out, close it again. So this is essentially a bar puller type job. Not a chuck job, a bar pull type job. So our coordinate system on this lathe, let's pretend this is in the chuck here, is Z0 is the face of our finished part. So on our finished part, we're going to set that as Z0. And so then as we go in this direction, we are Z negative. So this is Z0, Z positive, Z0, Z negative. On the X, 0 is our center line of the axis. X plus is this direction, X minus is that direction. It depends on how your machine builder set the lathe up, but you may have a different coordinate system. Some of these machines, and do not ask me why, they were X0 as you went out and X plus as you went in. That can be changed. Some people also, when they set their coordinate system up, they set their Z0 as the back of their part. And then, geez, I don't know why you would do that, but some people do that. Whatever you're comfortable with, and not going to hurt the machine. Do what you're comfortable with. So the way I set these up is I have a lathe setup sheet that I've printed out, and I just use this to kind of keep some things straight. So for this job, I've already gone ahead and entered some of my steps. So I've got the program already entered in the computer here. Yeah, here we go. I've got some notes on here. It says hang bar 1.5, so that means I'm going to hang my bar 1.5 inches from the face of the chuck. And number 1, that's my first operation, CNMG, positive rate. It's in tool station 1. And so that's what I've got here, operation 1, CNMG, turn and face, turret station 1, insert CNMG 432. If I search our next operation step, drill. So drill 406, and that is in turret station 6. And I'm actually also physically checking what turret station I'm in. So my first operation, turret station 1, correct. Turret station 6 for drill, correct. Cutoff, turret station 5, correct. If one of these is off, let's say last time I ran this, the drill was in 06, but this time I've got the drill in a different station. We would have to go in and modify this and anywhere else that there's a tool number. But in this case, I don't really move my tools around all that much. When I do big drills, they're in T6. Tool number 1 is usually my CNMG turn and face. Cut off in tool station 5, and then my bar puller is in tool station 4. Now, some of these I've already got my X offset written in. Why is it that I have my X offset already figured out? How do I know that? Well, these two tools are concentric tools. They are tools that operate along the center line of the lathe. You're not drilling with a drill at X.5. You're drilling at the center. So when you're drilling on the center line of the tool, of the workpiece. When you're operating a bar puller, you are operating it along the center line of the workpiece. So, how do I know that that's 18.89? I have a cheat sheet that shows me the distance between the center line of my spindle and the center of the pot. I call these a pot. So the way I figured that out was when I first got the lathe, I had these center working tools out, and in the spindle I put a dial indicator. And then I brought this in and I swept the spindle by hand on the inside of the pod until I had it indicated in. And then I could look at my display on the lathe and I saw that the center line of this was 18.89 inches from the center line of the spindle. Now let's talk a second about X, the X-axis of the lathe. The X-axis of the lathe on this machine displays in position in diameter. So when you tell the lathe X to go to X 1.0, you're actually only a ½ inch off of the center line of the spindle. But when you sweep that, that gives you a 1 inch diameter. So everything on this machine is programmed in diameter. So I've got all my tools physically in the spindle, or excuse me, in the tool changer. I've got my workpiece in appropriate work holding. I've got my chuck pressure set correctly. So now what I'm going to do is I'm going to set the workpiece distance in Z. Where do we need this to be in Z? Should we have it out here or should we have it way in there? Well, our cutoff, the last tool that works is this cutoff tool, and it comes in 1.275, I believe. So we've got to be out more than 1.275, and then on the tool holder here, it sticks out another couple hundred thousandths. So we don't want this to be out too far, but we don't want it too close either. So we're going to add 250 thousandths approximately to that, and we're going to do 1.5. So we're going to bring out our Z0 to 1.5. That's how far out we're going to pull this. But since we're going to do a cutoff here, this is a rough cut here, we're going to add 30 thousandths to that so we have a little meat to cut off. So we're going to set calipers to 1.530. And we're going to bring that in. Now, first thing we need to do is establish with our first tool a 0 on the part. We're going to do that in Z, and then we're also going to do it on X. Now we're starting to get into talking about G50 and being able to set our coordinate system. So to do this, let's change over to our number 1 tool. So in this machine, that's either handle, jog, or rapid, and then we turn our entry knob to turret, and we turn that to turret station 1. This has got a weird setup here. They have what they call their entry knob. This is cooling on, cooling off, spindle on, spindle off, high and low range, which this machine only has 1 gear and spindle. And then you set that all up and you press the entry button, and then the turret will index. So we've brought that around to tool number 1, which we're going to use as our reference tool. So what we need to do is bring that tool in, touch it off on Z. Actually, we're going to make a little cut. So we're going to go to MDI mode, command, and we'll do G97, input, spindle 650. Let's do spindle 650, and then we're going to do M3 input. So we've got these 3 words in there, G97, so we'll do an RPM. Spindle RPM 650, start in forward. Okay, so now we got the spindle going. Go down to rapid, and we'll bring our tool somewhat close. Okay, now the spindle is reasonably close. We're going to move to handle mode, Z. X. Go over to position so you can see that. I'm going to take a little bit more than that. Now we're going to take a little cut. Okay, we're going to go back in MDI and we're going to do M5. Just because you won't be able to hear me with that spindle going. Okay, so what have we done? We've gone in with the number 1 tool and we've faced off slightly our bar. So what we've faced off here, we just faced this off. That is Z0. So with this tool, we are establishing where our Z0 is. Now how do we do that? We go to our position page and we can change these. We can just reset these. So we're going to do W, which is our Z origin. So now we have set the machine coordinates so that is 0. Z is 0, okay? We're not quite there yet. We need to face it off in X and figure out what our diameter is in X so that we can set that as well. Here's how I do that. Back to MDI. Let's start our spindle again. And let's take a little face-off cut in X. Back to handle mode. You can watch the position if you'd like. I'm only moving it in Z now. I'm not moving it in X. Back to MDI, we'll shut the spindle off. Okay, now what did we do here? Back to our position screen. We don't really care what Z is. We already established what it is. We know where 0 is. So this 2.1836 represents the distance between the tip and our Z0 that we established. So we've already got that established. But how do we figure out what X is? Obviously X is not negative 11.7. You know, we're only about you know, 1.5 inches or so. Our diameter of our material is 1.5 inches. So here's where we get in and measure. Get my caliper set up. So you notice when I took that little cut, I came out only in Z. So this X position is the same as it was when we made that cut. So we can measure and our diameter there is 1.486. Let me get my paperwork. Okay, So on our measured diameter, 1.486, and that is in diameter. So why did I measure that diameter? We need to know how to set our X, and we're going to use this to do that. So there's a couple ways to do this. The way that I have done it and the way I do it, I think is the safest and maybe the easiest for you to wrap your head around. What we're going to do now is we're going to do U origin. Okay? So now we've said that this is 0. Well, that's not right. That's not diameter 0. It's actually 1.486. So what I do now is I turn it into handle X, and I'm going to go negative 1.486. Now the axes are moving, and so I'm at negative 1.486 from that 0 that I established. So where is that now in relationship to the spindle? Well, now in X, the tooltip is at the origin. It is at spindle center line. Okay? Well, how does that help us? Now we can just reset it again. Now our coordinate system here completely agrees with where our number 1 tool is and our workpiece. We are now 2.1863 away from our 0 in Z, and now we are at the spindle center line. So we could, if we wanted, let's say go to X again here, and we could go out. We could go out like that. This still agrees completely with there. See, we're just a little bit above our material, 1.68. Yeah, that works. So how does this translate into an offset number that we can put in our setup sheet? Okay, here's the magic. That's not magic. I go back to MDI, go to command, and we do a G28 U0 W0. Oh, sorry. G28 input, U0 input, W0 input. Okay? So what we're telling this to do is reference point return, and to get to your reference point return, make no incremental moves before it. And this is important because if we did a G28, bingo bango, this would try to go back to 0 and then back home. And we don't want it to do that. We don't want it to do any intermediate steps. We want it to do reference return, no intermediate step, no intermediate step. So this is going to go from here back to our 0 point and turn our lights on. And it's going to do it at this speed, which is perfectly fine with me. Now look at our numbers here. Okay. So right here, our relative numbers are what we write in here. Okay, so our offset 13.1904, 13.3968. What do those numbers represent? In Z, that number represents the distance from, at the home position, the tip of our reference tool to our Z0. Let's do what I call a dummy check. Yeah, that's about 13 inches, all right? So what does our number in X mean? 13.1904. What that means is, in diameter, the distance between our tool tip and the center line of the spindle is 13.1904. That's in diameter. Divide it in half, what do you get? You get about 6.6, okay? 6.6. That's pretty accurate to the center line. That's my dummy check. I don't get the tape measure out when I do it, but in my mind, I'm doing the dummy check, okay? So that's where that number goes. This tool is now ready to be entered into our program. So we could, for instance, go into our program, and here on our G50, right there, When I send it from the computer, it's got X0, Z0. But I could put this number in right there. But we've got a bunch more tools to do. So let's set up another tool. We'll set up these 4 tools, and then we'll look at the program. Our second tool is a drill. So we need to bring that up. So we're going to go into handle jogger rapid, go to our entry knob. Our drill is at station 6, operate. Gonna bring the drill around. Now the drill, we already know what our X is because that's one of our pods that we know the center line of the pod in X. So we just need to do Z. So I want you to think about for a second here, is our Z number going to be larger or smaller than this 13? Okay, think about that for a minute. Is our Z going to be larger and smaller? And remember, these numbers here that are going to be entered for our X50 or G50, those numbers represent the tip of the tool to the part. So think in your mind, is that going to be a bigger or smaller number? Okay, so we're going to go into rapid here and move this tool in a little bit closer. Because we are not going to do X for this center working tool, our concentric tool, all we have to do is in Z. Now, because we are drilling a through hole, this is even not very critical a number because we're drilling all the way through the part. So getting to the 1/10 of a thousandth of an inch is not really critical for this particular tool. But I'm going to turn it into low. And I like to take something light colored and put it in between so I can visually see. Also, on something like this, you can kind of see the reflection of the tip. You can see the tip and you can see the reflection of the tip. And when they touch, that's when it's touching. Okay, I'm real close there. So I can barely, I can't even get a piece of paper or the trailer. That's pretty good right there. That's stuck. Okay, so we're going to go back into our coordinate system here. I don't care what X is. We don't need to know. But we're going to take Z, 0, because tip of our drill is at Z0. How do we know that's Z0? Because we faced it off with our number 1 reference tool. So now we can come out a safe distance. That's established. Now we're going to go back into MDI and do our G28 input U0W or U0W0 start. Watch our numbers here. This is going to take us back home. I don't really care what the absolute is here. I care about the relative, which is where we set our 0. So that W number right there is the number we need to set up in our setup book. Z offset 9.0804. Okay? Notice that's a smaller number. Let's dummy check that. That's 9 inches. There you go. That's our 9 inches. Because that number, that G50 number that we're going to enter, this one right here, represents the distance between our 0 on our part and the tip of that tool. So that tool's set up. Let's go do the cutoff. Cutoff is tool station 5. Operate. Okay, this cutoff tool is not a concentric working tool. It's a, diameter and Z dimension tool. Because we are actually doing turning and facing with this. So we once again need to touch this off in Z, and we need to touch it off in X. Now there's various ways to do this, and I'm sure some people are going to scream at me. Say, oh my God, I would never do it that way. I'm going to come in Z first. I can still see a little bit of space between those two. We're within a few thousandths there. So we're going to go back to our relative screen here. And remember, our companion axis to Z is W, W origin. We've established that now. We can come out a little bit, safe distance. We're going to do the same thing in X. Now in X, we've got to touch off on our little machine surface we made. So let's do that. Alright, that's really close. So, since we have touched this tool off on that machine surface, we know that we are pretty much at X 1.486 right now. So, to figure out, to get that to a G50 number that we can use, we're going to go to that axis, origin. Now we're going to take ourselves off the surface of the part, X plus, we're going to go Z out where we get it away from the material, and now we're going to make this, we're going to bring that axis down to negative 1.486. Okay, there we go. So now, this tool tip is along the spindle center line. So we reset that again. Now we are at a place where this completely agrees with the physical position of that tool. To turn that into a number, we can use Command G28 input, U0W0 input. And when we hit start, it's going to take that axis back to home, and this is going to be the number that we can enter. Okay, there we go. We're back at origin. Those numbers represent the distance in Z and in X that we are from that point. So here we can enter 133067, 131332. You can do a dummy check on that now if you want. Measure your 13, yeah, that's about 13, and that's about 13 as well in diameter, 6.5 inches, like that. One more tool, puller. Let's do that. The puller is in station 4. Handle jogger rapid, entry button, tool 4. Depending on your machine builder, this is all going to be different. Okay, so now we're going to go in rapid and bring that puller over. Now, because this puller is a concentric working tool, I already know what my X is. It's 18.8900. So really all we have to do here is in Z. Once again, like our drill, and it was because our drill was only going through, you know, and when we go through this part with the drill, we're going through a couple hundred thousandths of an inch. So whether I was in or out just a tiny bit, it's not going to make a difference to the precision of the part. We're just blowing a through hole through it. Same thing with this gripper. We don't have to get down to the 10th on this because the gripper is just going to shove it on a fixed distance. Chuck is going to open. It's going to pull it out. It's going to close. So the pulled out distance is going to be the same, whether we go on there 110 thousandths or we go 140 thousandths. It's not going to matter. But we're going to get it real close. We're going to go back to handle mode, Z. Turn it down to low. And here I'm really just going to use that piece of paper. Move it a couple thousandths at a time. You should start to feel that paper firm up a bit. Oh. My machine cannot hold tenths, let's put it that way. So now we're touching that Z0 face. We're going to reset this to origin. There's our 0. I'm going to bring it a safe distance off the part. We're going to go back to MDI. This is now accurate. We don't care about that because we already know the center line of that pod. That is accurate for this tool and our workpiece. So we're going back to MDI, G28 input, U0 input, W0 input. Start, position. See, that's going up, and that's going to be our number. There's our X offset, 12.4193 from W, our incremental companion axis to Z. So there's our completed setup sheet, okay? This information now goes into the program screen. Let's talk a little bit about G50. So now we're going to go into edit mode, program. Okay, so we're not at the beginning of our program. It's program number 1000, and we're on operation step number 3. Reset is going to bring us back to the top. Okay, so anatomy of this program. O, which is our program number, 1000. And then we've written in some notes here, right? This is not a full alphanumeric character set here. So if we wanted to add notes, we could use any of these characters. But there's some characters that are missing here. This is not a full alpha. It will display any alpha character. You just can't necessarily enter it from here. So I've given myself some notes. This is what the part is, and I need to hang the bar 1.5 inches. We've already done that. We added 30 thousandths so that we have some setup room to take about 30 thousandths off. Tool number 1. Okay, this goes per character. This goes per page. So we can go reset there. Okay. So, operation step number 1, G99, some preparatory stuff, G28. So the very first thing I tell the machine to do is go back home. Go back to your 0 return. That's a very safe thing to do, and you will see that in all of my preparatory steps. Okay? The next thing is, I'm telling the machine is, G50, reset your coordinate system. And I'm going to tell you where to reset your coordinate system. And that is where we enter this number here. So we're going to go and highlight that first X word. And we're going to say X 13.1904. Okay? And I make sure it jives. And then we hit Alter. And it will substitute in that X. Now we go to the Z. And we say Z 13.3968. Alter. Okay, now we have entered our G50. So what will happen when we run this first step? The machine will go back home to its safe return position, or 0 position. So no matter what the situation of the machine was before we hit go, it's going to go back to the home position. Once it gets to the home position, we're going to tell it, your new coordinate reference system is this, and you are now presently located at that and that, okay? And then we tell it to change tools. So, you could argue on whether to flip-flop these two. That could be argued. So here we're saying tool, change to tool number 1, and in state, tool offset number 1. This is probably not the right way to do it. This should probably be T0100, okay? Because on this machine, here's our offsets. I don't have any offsets in here. I generally don't do wear offsets because I'm running aluminum. We're not going to be going anywhere here. That also has a tooltip radius if you need it. So if I was being strictly correct here, this should be T0100. Call the tool physically, move the turret, do not instate any offsets. Then our next step is G96. Go into a constant surface footage speed mode. We want spindle speed 550, surface feet per minute, M03. Turn on the chuck in a forward direction. Next line, G50. Well, why is there a G50 again? G50 is used for two things in these machines. Remember what I said about memory? There ain't much. So they've reused G50. G50 is also valid with an S word after it. Okay? And what you're telling it here is G50 S3000, spindle speed 3000. We are telling it a maximum spindle speed. Even though we're in G96 mode and we're giving it a surface feet per minute, we're telling it in G50S that a maximum RPM limit of 3000 RPM. So as the spindle approaches 0, it's not going to go to 6000 or whatever this machine will do. Okay, next command then is a rapid. So now we're getting ready to do some work. Rapid to X 1.6, which is a tiny bit above the OD of our part. Rapid to X 1.06, Z0. So you're asking it to come right there and turn the coolant on. And then our next line is start machining down the face at this feed rate. Okay, so why did we go through all that? That's basic stuff, right? This is basically my preparatory block for setting up for any tool. If we go a page down, here's some more machining, and then to take ourselves back out to where we could change the tool and do our next operation, I take it to a safe distance in X, I bring it back out to Z0, I turn the coolant off. At that point, I uninstate any geometry offsets, and then we go to send it home. I am going to change how I do this a little bit. I should probably not uninstate a geometry offset like this, because this can cause the axis to jump. Because when you uninstate it like that, with that 0, 0, it will jump a little bit. It can. It'll jump by that amount that you have in your offset table. So really this should be done during a return move, okay? But as I said, I don't put geometry offsets in my offset page. It's never been an issue. But some people that want to use geometry offsets, or excuse me, wear offsets in here, you may need to program a slight bit different. Now we're to our drill. So once again, we're going to come down here and enter our numbers. So G50 X 18.8900 alter, Z 9.0804 alter. Okay, there we go. Now we're going to use, and the other thing I check is I check to make sure that our tool numbers match. The worst thing you can do, let me point this out. Let's say this drill, the program was written that it was in tool number 6, but let's say that I had something else in tool 6, and I put this drill in tool pocket 4, and I went down here and I changed this. I said, okay, well, I'm going to run it in 4, T0404 alter, right? It's great, right? Now it's going to bring up that tool. Machine, 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 machine. Uh-oh, what happens there? I forgot to change that T0600 to 0400. What is it going to do when it gets right here? That machine, while being 100 thousandths away from the face of the material in Z, is now going to do what? It is now going to do a tool change, and it will crash. I cannot stress this enough. This machine does what you tell it to do. If you tell this machine to punch itself in the face, it will punch itself in the face. And it will scare the crap out of you and possibly damage your 1982 machine that you can't really get parts for. So, you must be extremely diligent when you are changing tools from a proven program. And the way I do it, if I was going to do this, I would do that change and I would do a T-search next, right? Because you can scan through with your eye and miss something. You would press T and then you go next. It's taking you to that next one. We could now change that to T0404. So we're going to go back up here and change this before I make my machine punch itself in the face. Okay, so we've entered that. Now we're going to do a number search, all right? So we number and then search down. It's going to show us our next tool, cutoff tool. We're going to go back to our G50, X13.3067, alter. Z13.1332, alter. Okay. That's in tool number 5. Sounds good. All right. I've thrown something at you here. Second piece. With one setup, we're doing 2 of these. We've just cut off one of them, and now we're going to come in with our tool again, and we're going to machine a second piece. So, because that's the same tool, we still put the same numbers in there for tool number 1. Now, this is the place where you're going to say, okay, now, Carl, this is why you really need geometry offsets and not doing this G50 business, right? Because now, if we decide that one of these numbers is slightly off, we need to compensate for it. We have 2 places in the program that we need to enter that. I get that. That's a valid reason for work offsets, geometry offsets. And if this was a more modern machine, trust me, I would not be using G50. But it is what it is. So we got a second piece cutoff. So we're going to do this again for cutoff. But the kind of parts that I make, oh shoot, I got that wrong. Yeah, I made it mad. The kind of pieces that I make are not complicated. I'm not doing hard tool steel in this. So we're going to do cut off. So a lot of times my numbers don't really change because you're not really wearing a bunch of stuff out doing 100 pieces in 6061 aluminum, right? Okay, now we're to the bar puller. So here we've got our G50, and I actually still had that X in there. Z12.4193, alter. Okay, so now I hit reset and I go back in, and I go through every one of these one last time, and I just put my eyes on a couple things. Tool number. I make sure that tool number jives with where it is physically in the machine. I make sure that this number matches that number, right? I look at my tools, tool number, tool 6, 18.890, 9.0804. Cutoff, tool 5, 13.3067, 13.3. Okay, second piece, back up to our CNMG. That's right, T1. Okay, cutoff. Back to the cutoff, that's our second piece. Bar puller. Okay, program. Okay, now we are at the point where we can prove this program out. What do I mean by proving it out? First of all, it's a proven program, okay? I have run this program many times before. So, unless I mess something up, or the program transferred incorrectly, but this has parity check, so that's not likely. I could just hit go and run this at full speed, 100%, automatic, memory. You could hit go right now, and that would probably be fine. But we're not going to do that. We are going to single block this program just to make sure. When I single block a program, I usually do it at a low speed there. And I am watching my position numbers. I go in this screen here, and what I usually watch is this distance to go. Okay? Very handy feature. So let's set up to prove this program out one step at a time. And I'll kind of show you, I won't really be able to show you in the machine so much because I do have coolant set up. But, well, maybe we'll turn the coolant off. We could probably do that. It's time to prove the program. How are we going to do that? We are going to do that. We're in edit mode still. Reset. We're at the beginning of our program. We're going to turn our rapid speed all the way down to low. And we're also going to turn on single block mode. So what this is going to do is every time we press cycle start, it is going to go down a new line of program. What I do in my head, and I know what all these things mean when they come up here, and you need to as well. Every time I press the button and it does a step, I look at the next line or two and I say in my head, do I know what the machine is going to do next? Is that a valid thing for the machine to do? Especially when you start getting in down to machining. The things I'm looking at are X and Z moves in the negative direction, right? And especially with Z, the surest way to crash a machine is some kind of crazy Z negative move that you weren't expecting. It was supposed to be Z negative 0.103 and you entered Z negative 1.03. You're now sending the machine an inch into the part, which is possibly where the chuck is, and that's where everything goes tits up. So I'm looking for wildly inaccurate Z negative moves. I'm looking for wildly inaccurate X negative moves, okay? That's the kind of thing I'm looking for. I'm just kind of scanning ahead as I cycle start through the various things. Now, when we go through the preparatory steps, we'll get down here to where the spindle is going to come on and it's going to want to start moving in rapid down to X 1.6 Z0. This is where we really start to perk up, okay? And when we get down to here, I'm going to change over into position mode and I'm going to watch distance to go. And those numbers are going to start up at 13 or so, and they're going to be going down, counting down to 0, 0, which is where we've told the machine to go. Not absolutely, incrementally. We've told it to go to 1.6 Z0. We're going to watch these numbers count down. As they're counting down here, we are watching in here, and we're usually watching through the window, right? But we're going to be watching that as they approach. And what I'm asking myself is, does this number reasonably look like the amount that I think it has to go? There's your dummy check again. If this is coming down here and you're down to a Z 10 inches to go, and you're right here off the surface of the part, you need in your head to start saying, wait a second, we don't have 10 inches to go. There's only 2 inches to go. Feed hold, stop, okay? You can always press feed hold. Regain your control of the situation, analyze if that number matches what you got going on in the machine, and press cycle start. There's very few machines where you can't just press feed hold at almost any time. Now, if you're tapping a part and you're got the tap buried in there and you press feed hold, yeah, you're gonna have a problem, but not with this, okay? So, single block on, low speed. We're going to go from edit to memory mode, and first we're going to go program, memory. So, now we're on high alert. Press cycle start. It's just reading a comment, nothing going on. Next line, comment. Okay, now we've got a number. We're up there. G99. G28 U0W0. Nothing happened because it was already there. Okay, now we're going to reset the coordinate system. Now if we go back to the position now, next line. Okay, now we just reset the coordinate system. It just executed that line. So now, there's our absolute. We just, with that G50, reset our absolute coordinate system. 13.19, 13.39. That was just that line right there. When we executed that G50 line, all we did in the machine was reset our absolute coordinate system, okay? Program. Next line, T0101. What's it going to do there? It's going to index our turret, and it's going to call up that offset number 1. Now, there was nothing in offset number 1. And like I said, I probably need to change how I do that. Program. Now, next thing it's going to do is start the spindle. It's going to get a little loud here, so let me walk you through this before we start it. Next time I press cycle start, it's going to put it into that mode, start the spindle, and then next we're going to set the spindle max of 3000. And then once we get down here, I'm going to turn it into position mode, and you can watch as it comes in, and we're going to watch together. We're still in low, right? So here goes. There goes our spindle, right? Set our max. Here we're going to start moving. Distance to go in Z, 12 inches. That looks reasonable, doesn't it? Yeah, looks good. If we're feeling sporting, let's turn it 25%. Okay? Whoa, stuff's going on now. Whoa, low, low, low. 3 inches, right? Feet hold, hold on. I'm not quite sure. We have 3.4 inches to go in Z. Does that look reasonable? I think it does. Cycle start again. Let's be real low here. Okay? All right, 2 inches to go. Looks about 2 inches, right? Good. Hover on that button. That looks good. We're right where we need to be. So now, I'm going to turn this up, turn off single block, and let it run the rest of that program. I'm going to turn single block on again as it goes back to the back, okay? What that lets me do is recollect my thoughts, change some stuff around again before we start running in single block. Now, I'm going to have to close the door now because the next one is a drill. And we got to run coolant for that drill. So here we go. We're going to do the same thing though. Memory, single block. It just changed the tool. We're changing our max speed, and here we're going to go towards X0, Z.1. Back to position. Let's watch that distance to go. I'm watching through the window and I'm looking at that Z number. I'm hovering on my feed hold button. Okay, it looks good. We're in place. Single block off. Let it have some speed. Finish that. Okay, it's going back home. I turn single block on. Okay, it's back up at home now, and it's waiting for us to press cycle start again. Okay, and we got a hole in our part. So cut off, same thing. It's going to run coolant. Let's close the door. Okay, 13 inches to go in Z. I'm going to watch through the window. About 2 inches to go. Yep, that's right. Looks good. Let's let it do its thing. As it's going back home, I turn single block on. Okay, now it's going to bring up our turn and face tool again to make our second part. Our first part is already dropped. Watching that number again. And about 3 inches away. Yep, 3 inches away. Hand on the feed hold. Looks good. Allow it to run. It's going back home. I turn that single block on. Okay, so what's going on now? We just turned and faced the second of our parts. And now the next thing it's going to do is bring that cutoff back again. Single block, slow. We can step it through. Step it through a tool change. Reset our spindle speed max. Feed. Move in, 13 inches to go. About 3 inches away, yeah, looks good. Okay, single block off, give it some speed, let it run. Okay, it's going back home. Okay, so the next thing's kind of cool. We can leave the door open for this. Next, we've got this tool called a bar puller. And really, it's just some springy fingers. So let's single block that. Okay, we just reset our coordinate system. M12 on this machine means the next time you do a tool change, do it backwards. This machine is not smart enough to figure out the fastest way to the tool. And this tool is one below the one we just used. So I put the M12 in so we don't have to watch it go around the whole way. Okay, so now we're going to go to X0Z negative 1.224 because this has been cut off. So let's put ourselves in position and let her go. Okay, so once again, I'm really watching that Z, 12 inches. Yeah, we're about 12 inches. Let's turn it up a little bit. 9 inches, 8, 7, 6. Okay, I'm getting a little scared. 3, 2. All right, turn it back down. 2 inches. That's pretty reasonable, right? Okay, about 1 inch to go. Let's hover on that feed hold. Okay, I mean, it looks like it's right there, doesn't it? Okay, so now you can see we've got this little bit of room there. So let's not run this into the chuck, right? Let's go look. What's the next thing it's going to do? Well, we're going to put it into G98, which means allow it to move without the spindle moving. And we're going to go another 250 thousandths in. Ooh, we're actually going to be pretty close here. So, oh yeah, see how close we are there? It's pretty close, but like I said, I've run this program before. And then M21, open the chuck. G4, which is a pause, and now move the part out at that feed rate. M22, close the chuck, little pause. Because on this machine, you tell the chuck to close. There's not actually there is a chuck clamp, but as soon as you tell it to close, it considers it clamped. So we give it this pause to make sure it's closed. Okay, so now G99, call out the thing, and then we're going to tell it to go home. There she goes. Okay, so what did we get for our efforts, right? And now we're still in automatic mode, okay? So even though the program's pretty much done, I turn it into edit and I reset it. edit and reset it. And then when I'm playing with the machine in here, I am not in automatic mode. I'm in edit mode, right? Turn that single block off. So that's what we got for our efforts, right? A couple bushings that low tolerance deals here, right? So if I look at my drawing over there, I want them to be about 1/2 inch thick. That is definitely close enough. I'm not going and changing anything for that. This is not even a critical dimension. So yeah, that's pretty good. So the one thing I do look at on these parts is the chamfer here. One of these is done by the turn and face tool. The other one is done by the cutoff tool. So that one was done by the cutoff tool. Looks pretty good. So because this is really just a 2.5 dimension part, I'm not doing tool nose radius compensation on this. It's baked into the program, how to do that 45-degree knockoff. I just didn't feel like it was necessary to do that. So these are good to go, right? We can just hit go on this. So what I wanted to show you as a bonus, I gotta do a lot of these. That particular part there, we need to run that we need to run that 80 times, right? Okay, so we got to run that 80 times. So I know from my drawing that this takes 1.304 inches of material total. Okay. I started with a 48-inch long bar. So that was a 48-inch long bar that was in there, okay? We have to leave ourselves a margin of safety. What we're working towards here is doing this automatic, right? So we need a little margin of safety for what's stuck in the chuck. So let's say that out of our 48 inches, we're going to take out 2.5 inches, all right? So we've got 45.5 inches of bar to work with. And then what did it take to make this? It took 1.304 inches of material. So we can safely run this 34.9 times, okay? So 34.9 times. Let's run it 32 times. How do we do that? All right, this is program number 1000. So we're going to go and search another program, this program. And what this program does, this is a repeating program. So itself has a program number, program 2000. What this does is nest, okay? The P word is what program to call. So this is calling a subprogram. 1000 calls our program that we just set up and ran. The L word controls how many times it runs. So we're going to change that to L32. And M98 says do it again, right? We're going to do that until it's done, and then it will knock itself out of there. So if we go and we search for that 1000 program, it's going to run this program 32 times, okay? But we have to run this program. We don't run program 1000, we run this program, okay? And it will run that many times. So theoretically, when it gets done running it, we should have a lump like that in the chuck. We don't want too much sticking out. It means we can run more pieces. But you don't also want to be gripping on the very last bit, because you know what happens then. This gets flung out. So I ran it about 2 iterations too short, okay? So I only ran it 32 times. It said we could run it 34.89 times. So let's run it at 32, and then we can just hand run it the last few times, right? To dial that in. Because I'm going to have to run more than one bar on this. And remember, we also already took one off. So by running this 32 times, we're actually running it 33 times, okay? So we're ready to go balls to the wall here, right? We got single block off. We've got our feed rate at 100. And we're in edit mode. We're at the top of our program. Reset. Turn it to memory. Close the door, right? Cycle start. So now if you're in program mode, it will just show you the program as you run it. You can watch it step through. If you go to position mode, you can watch each tool run. See? Boom, that was our G50 right there for the drill. That just knocked the G50 in there. We're drilling the hole right now through the whole thing. Okay, so what's going to go back and boom, there's our G50. That was the G50 command that changed our coordinate system. Cutoff tool. There it's just bringing up our turn and face again. Second piece. We come in and machine down. Out. Over. Watch that G50 change here. Boom, there's our G50 again for cutoff. So the other thing you can watch, command. Showing you the commands it's running. Page down, this shows you actual speed of the spindle, maximum spindle speed that it's set, and this L word, remember that L word? That L word set how many times the program ran. We told it 32 times, right? It's just about to finish running the first set of the program. Watch that L word. Okay? It's going to run it again. So with this screen, if I'm running automatic operation, I'm usually watching this screen right here. If you don't want to burn your CRT out, all you have to do, press a button and cancel. It'll turn the screen off. That way you don't burn your CRT in. You want to see it again? Press program or press offset, any of them. Press it, hold, cancel. Yeah, there you go. That's it, we're running. Well, I hope you enjoyed watching how I set up my Ikegai lathe with the Fanuc 6T control. There's more than one way to set that up, coordinate system wise. And one method's not necessarily any worse than the other. The biggest reason I set it up like that with the G50s is that I think it's the safest way to do it. Now, one thing some of you are probably screaming in your head is that, oh, that's so slow, you're doing all your tool changes way back at the home position, right? You're right, that's true. I do all my tool changes back at the home position. The origin lights are on, we're back home, right? So you don't necessarily have to do that. You could set another reference point as your G28 reference return point. You could set that up, and then that would become your new zero that you would G50 off of. But you really got to understand, you have to have your head completely wrapped around the coordinate system and how that works. And what can happen is, let's say you had to stop a program mid-tool and something wasn't going right, you had a broken insert or coolant nozzle wasn't in the right place, and so you stop and do the steps you need to correct that situation. Then you go in to rerun the program. If your program start and stop kind of operations aren't 100%, up to standards, then you could get yourself in a situation where your coordinate reference system is not correct because you haven't, let's say, run the first line of code. So something that would run great if you just ran the whole program all the way through, if you have to stop it somewhere or rerun a step from the middle, you have got to know exactly what you are doing. If you are doing something where you have a reference return or a tool change point that is not all the way back at the origin. So for me, and my skill level, and my appetite for carnage and destruction, I'm just going to send it back home, okay? It's not a speed demon to begin with, right? This machine is not doing 2,000-inch rapids, okay? So, so for me, a little 5 seconds more of tool change time for tool is perfectly acceptable. So, but of course, if you have really got your head wrapped around that coordinate system, by all means, do a tool change closer to the chuck. It's just, the danger goes up. So that's up to you. But that's how I set it up with G50s. And I should probably do another video talking about the program preparatory blocks that I use. The kind of the setup part of the program at the top of every tool I'm going to run, and the one at the bottom. And I probably should change that a little bit because the way I instate the offset, the like T01, 01, I should probably change where that instates. And the same thing with how it goes out. I should probably outstate that in a different way, so that if I wanted to use wear offsets, I could. Because the way I've got it now, I don't really ever use the offset page. If I run a program and my diameter is a little bit off, for instance, I just go back in my G50 line, G50 X whatever, and I just add or subtract what I'm off, and it right in there and run it again. And I understand there's probably some more efficient ways to do that, but like I said, at my skill level, in my threshold for pain and carnage, that's just how I do it. So, these older machines, the iron is great. The control is obviously dated, but this thing starts up every time. I'll tell you what, if you look at the construction of the circuit boards and the integrated circuits that are on it and the logic that's on it, it's all ceramic package, some gold plated, it's like military stuff. This was very, very expensive when it was new. And one thing I think is interesting, this machine panel, it has like 8 LEDs on it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It has 13 LEDs on it. 13, can you believe? LEDs back then were like probably on the orders of tens of dollars for one. So the fact that this had LEDs on it and not indicator lamps is like, so, but for me, it's a great machine. Good old iron, and for what I do, that's perfectly acceptable. So I hope you enjoyed that. Keep your machine running. We'll see you next time.